Excellent. Well, welcome all. I'm Erin Reed. I'm the marketing manager for Polaris MEP, and we are the state's Manufacturing Extension Partnership Center. That is what the MEP stands for. And I'm really excited today because we are kicking off a great new series that is really wonderful because it's exactly what Polaris MEP does for our clients who are all small and medium-sized manufacturers. We're always on the lookout for things that are proven and generate a really high ROI, giving you back more time, giving you more capacity, helping you reach your goals. And so today I'm delighted that Ted Kennedy, who is one of our project managers, will be talking about spaghetti diagrams and kicking off this series of 4 tools that are all productivity tools that you can use to improve your business. So Ted is a Six Sigma black belt. At Polaris MEP, he manages a variety of projects and works with our clients as a trusted manufacturing advisor. And I have shamelessly, from the marketing side, used his expertise twice this week. Yesterday, he was talking about supply chains and de-risking at an event for manufacturers. And today it will be about spaghetti diagrams. This is a small group, so if you have questions, please toss them in chat or even unmute and holler out. Let's keep the conversation going. And I know that we're going to learn a lot from Ted about the why and what of spaghetti diagrams. Ted?
Thank you. Yes, yeah, it's a small group, so we can keep it very casual. So if you have questions, please answer them. Ask. I decided to do this series because I've used all these tools in the past and had really good benefits from it. The first one we're going over is spaghetti diagrams. I used that at my old company I used to work at, and we did it in one large department in the company, and we implemented changes based on it and probably saved 30% of the space in the department. We really condensed the size of the department down, and we made things very efficient. I'd say we got like 10% productivity increase by implementing changes through the spaghetti diagrams. So as Erin said, I'm a project manager at Polaris, and I've been here for 3 years, and I'm an industrial engineer, so I've done a lot of these tools many times in the past. So please ask questions whenever you want. So the first thing we're going to go through is what we consider waste, and what do we mean by value-added processes? Why make a spaghetti diagram? What is a spaghetti diagram? How is it created? And we'll go through a question and answer period. Basically, we want to look at processes and movements to see if they add value to the customer. Does the customer want to pay for these activities, these movements of people and material through your building? So it's basically looking at it from their perspective. So Polaris is a group, a nonprofit group, and we help small and medium, usually manufacturers in Rhode Island, improve, grow, and increase their profits. We help you with your top line and bottom line, and we do a lot of training with manufacturers on productivity tools like the ones we're discussing today. So what is waste? There's many types of waste in a system. There are the ones that basically do not add value to the customer that we're focusing on. The customer does not want to pay for certain activities, since they don't think it's adding value to the product that you sell. So does anybody know any of the wastes that I'm talking about? Anybody want to say any of them? Or does Erin have one?
I do. Defects. Defects are a waste, right?
Yes. Yeah, defects. Yeah, defects are a waste. Customers do not want to pay for the defects that you make, of course, right? Does anybody else know any other wastes that customers wouldn't want to pay for? No. So I'll go through some of the wastes. So there's defects, overproduction. You make too many of the product. They don't want to pay for your inventory of the overproduction. Waiting time, people waiting for activities in your building. waiting for work to come to them. They don't want to pay for that. Non-utilization of talent. You're not utilizing people to their full ability. Transportation. You don't want to pay for excess transportation or movement in your building. Excess inventory in your building of components or anything like inventory bills between operations. Motion, which could be excess processing that you're doing, excess movement in your building, and extra processing. For instance, inspection operations. Customers don't like to pay for you making a product and inspecting it. They don't like to pay for the inspection operation. They like you to make the product properly and correctly the first time. So a spaghetti diagram is like a pile of spaghetti, as you can see. You track and look at the waste, like the transportation and motion and waiting time of the products going through your building and people walking through, transporting parts through your building. And when you diagram what people are doing and the movement of material, it often looks like a pile of spaghetti. Movement is all over the place. And that's what happened to my old company. We were shocked at how much movement we had in the building. Moving from one side of the building to the other to do processing, to complete the product production. So it's a tool to look at motion and movement. Why do you do it? Again, the customer doesn't want to pay for this wasted movement in your building. It doesn't add value to the product that you're making for them. Even your employees don't want to do all this excess movement. If you ask them, they don't want to move something from one end of the building to the other and back again to the other, a different part of the building. And with labor shortages, no manufacturer should waste all their time, their workers' time or skills doing this unnecessary movement. So why make a spaghetti diagram? Well, we want to create a system that adds the most value with the limited resources. Value, again, is from the customer's perspective, what they think is value. We want to look at processes and movement to see if they're adding value to the customer's product. And by using this tool, we can eliminate the cause of this waste. So what is a spaghetti diagram and how is it created? So a spaghetti diagram is one that uses your current layout to show the movement of information or material through your system. So you should have a current layout mapped out of the area of the building you want to do this analysis on. Then you look at the distances and waiting times between people moving material throughout the operations to make the product. So you do need a layout of your current operation, and you go out there basically watch what's going on out there, and with a marker, observe what people are doing and where they're moving material. So you can see an example on the screen with material flowing through, and you can see the mess in the middle here. This is like the pile of spaghetti developing. So but you must get some information through observation to make this diagram. Do not sit at your desk and to draw out the spaghetti diagram. You've got to actually go out there and watch what's going on. And spend some time observing orders or processes going through the system. And make sure you look at travel distances and waiting times. I've seen people make spaghetti diagrams by sitting at their desk and they think they know where the products are moving and where the people are walking, but don't do it that way because you're going to miss a lot of activity. You got to really go out there and study the operation. So, like for instance, this is a spaghetti diagram, like an initial one of making a car battery. So you can see how the first step is the orders received, then it goes over to a store, and then it goes over to a setup machine, and so you can see all the movements throughout the operation. The total distance is 113 feet to do all this movement. And there's 440 minutes of total time involved in all these movements. So what do you guys think of this spaghetti diagram that was created? Do you see any ways you could improve this operation? Does anybody have any ideas?
Andrew or Kirsten or Greg, anybody got a thought on this?
The layout, how it's laid out.
Yeah, the layout.
Conducive.
Yeah, you're right. That's the whole issue with this. So the layout, it's not a proper layout. So you could definitely be rearranged to make it much more efficient. And how it's very low in cost often to just rearrange operations, right? And you can rearrange them so you cut out a lot of this wasted motion. And that's the benefit of doing the spaghetti diagram. So we can look at another diagram. So the proposed spaghetti diagram. So initially you do a current state diagram, and then you look at a new diagram, the future state. So you do that by having you look at the current state one with team members and study the flow and brainstorm new ways of coming up with a flow that cuts travel time. And the new flow, you should also look at inspection points or processes that might be creating errors. Maybe you can eliminate some of those and try to reduce the movement between the operations, possibly move them closer together, cut down the distances. And that's where I saved a lot of space. And when I did this before in my old company, there was so much distances between the operations. And basically we moved them together as much as possible that made sense right next to each other and cut down on the movement distances. And by doing that, you have people doing one operation and handing off directly to the next operator. And another benefit of doing that is errors are caught immediately. You don't have big inventory builds up between the operations. You want a nice steady flow of material between one operation and the other with low inventory bills, because those inventory bills could be defective parts. So you could have created 100 defective parts for the next operator. But if they go directly from one operator to the other, they'll find the errors immediately and can tell the prior person, oh, you're making bad parts. So you can get a lot of benefits from it, even from that, reducing scrap. So here's a new arrangement for that operation. So you can see things were put in order, and this is what I did in my old company. And operation 1 is put next to operation 2, so the parts just flow between the operations like that. This is kind of called a work cell. This is something I've created a lot of times in the past, and it creates a lot of benefits to doing it. Like I said, with the defects being caught between the operations, and just the movement is reduced. So this is 33 feet of total movement with 130 minutes of total time to get through the operation. So you can see it's a drastic change between the prior one. So it went from 113 feet of movement to 33 feet. So, well, what do you guys think of this setup? Isn't this a big improvement? Do you see anything else that could be improved from this setup? I'm not sure I can, but I'm just asking if anybody sees anything.
I was gonna say, don't be shy.
Don't be shy.
So one question I had, Ted, so that's cutting out 300 minutes, right? Yeah. And you didn't add any head count in this. You didn't have to retrain people for this.
No, there's no head count change, no retraining people. We're just consolidating the operation, putting more in order, putting it as close together as possible. And I'll tell you another benefit of this by having since we're on that when you create, this is more of a work cell. So you have a person at each one of these operations. Now that it's a nice condensed work cell like this, what could you do if your customer demand is cut by 50% for some reason? Your customer orders go down 50%. In that case, in an arrangement like this, you could have people do 2 operations. One person does these 2 operations because they're next to each other. One does these 2, one does these 2. So if you can get them close together, you're creating a flexible output production operation. And I did this at my old company. It was really beneficial because my old company, we made automotive parts for Ford, GM, and Chrysler. And their output would change their demand, and we could flex the demand with no decrease in productivity. You can still get the same productivity. And it's really amazing what you can do by creating these work cells.
Absolutely.
Yeah.
So I have a question for the people who are on the call. How many of you right now are hoping to increase productivity, hoping to increase your throughput? Can you put in chat if that's something that you're experiencing? Or you can just unmute and tell us.
Yeah, don't be shy to talk. I mean, there's only 6 of us, so yeah. So if anyone wants to ask any questions, talk about their operation.
Yeah, because I was especially curious when you were talking about kind of that idea of the flex as well, Ted, right? Like it seems like spaghetti diagrams give you more flexibility with people as well as responding to the volume of customer orders, right?
Yes.
People also have different days. And so, if you're missing somebody one day with this approach, you could have somebody working 2 machines just for a day, and then get back into the flow of things without too much disruption.
Yeah, that's what we did also. So you're missing 2 people call out sick, but you can still run the operation. You might get 20% less output, but at least you can run it very productively.
Yeah.
The other way is it's difficult because you got to have a person running, in this other way, a person's running this machine, and then they're running that, and then they're waiting for parts from another machine, and because there's somebody missing down here, and it just doesn't flow properly. But using this other method, it flows very well in creating the work cell.
Yeah. Absolutely. So Andrew says that he's always looking to improve productivity. And Kirsten says, I am looking to increase productivity and flow of building assemblies. What is the best setup to build and how to figure out different layouts quickly? So that leads me to another question that somebody had private messaged me. So people are being a little shy, but not too shy. And the question, and maybe this is a good time to do it since you're looking at these kind of examples right now, how long does it take to actually make a spaghetti diagram? How much time does it take to make the initial recording of observations so that you can then create that, okay, now this is the new layout I'm going to test?
It doesn't really take long to create. It depends how many operations, but typically in a day you can get or less, you can get all the movement. You go out there and watch the operations and talk to people.
Have a stopwatch.
You just watch, stopwatch, and you watch the flow of the material. And one of the key things is, though, you should have your building layout, ideally in like a CAD, like a software package. And that's the way I've always done it. By doing that, when you come up with the new method, you can move the machines easily in the software to rearrange things, and then you can come up with a good arrangement before you actually implement it. You've got a nice solid arrangement that fits together properly, and hopefully it creates a lot more space in your building also. Yeah. So that's the idea. So first you create the layout, then you go out there with like a marker and start marking the flow of the material in the building. Like this. So like this one is this was a real life one that I found that was done, and it's following the patients going into a like a triage area, and Like the red signifies female patients and the green is male patients. So when you look at this, like most of the people come in and they go in these waiting rooms, and then sometimes the waiting room's full and then they have to go to another waiting room, and it's very confusing. But looking at this, the female patients all go way over here, and the male patients go down here, but they got two vitals rooms here. Like, do you see any way you can maybe arrange this so it looks like it would work better? Does anybody have I don't have a future state one, but does anybody have any ideas on this one, out of curiosity? You see, like, based on this, do you see how far out the female patients have to go? What do you think of that? Does anybody have any thoughts on this one?
Andrew, Kirsten, Greg, anybody? So for me, I'm just curious, if they've got two vitals areas side by side, why are we sending the women to another building, basically? Like, couldn't one be the female vitals area and one be the male vitals area, but still right there at the entrance?
Well, that's that's my thought. I mean, I haven't done a future state on this, but that's what I look at. Why not have a vitals for women, for females, and one for men, and have them both next to their waiting rooms? Why have people walk all over the place like this?
Yeah.
Right?
It makes it so much more evident, right? We may have had an underlying sense that it took somebody longer, but if you've got the actual data this way, and you've done your stopwatch, right, to mark the number of minutes, or you've used the measurements to say the number of feet traveled, that's hard to argue with that, right? It takes a gut feeling and turns it into something that everybody can act on.
Yeah, and it's so this is the way it makes the most sense to do it this way, with color code the movement also. The one in my old building, we had probably 30 or 40 movements per product, and we had, I don't know, 30 or 40 products in the department. So we had many, many colors. Each product we put a color on. So it was really a total pile of spaghetti. And that one took a while to figure out a good rearrangement, but we had multiple meetings with the team, got everybody's ideas, which is very important. And we came up with a really good layout that worked well. Because sometimes you got equipment that 3 or 4 products go to one piece of equipment, and it's a shared piece of equipment. So that adds a little complexity into this. So you can't just take all the equipment and group it for one product. Often it's like shared equipment, but you can still come up with a new layout to do that, to make it much improved. But you have to work on how where the shared equipment is. Maybe it should be in the middle between all the production operations, possibly.
You're actually reminding me that we did a project, Polaris MEP did a project with a client where they actually discovered that if they moved one shared kind of parts and assembly place to the center, they saved days worth of wasted movement. So it was a really good thing. Excellent. Thanks for answering these questions, Ted.
Yeah, so, oops. Yeah, so some of the do's and don'ts when doing the spaghetti diagrams. Don't draw this is an important one because I've seen people do it. Don't draw the movement between walls. Like, you don't go, you gotta have a good layout of your operation, and then do the actual path of the movement. And don't ignore any steps in the process. Go make sure you get all the different steps to make the product. Don't miss any of them. And do follow the movement of each individual. So don't miss people walking in the building. Sometimes people have to go other places to get tools. Don't miss that. So they're doing one operation, but they have to walk and get tooling from some shelf in another part of the building to complete their operation. So you got to put that on the map too. Any movement of the person to make the product. And I always engage with the operators, and it's nice to have them go through the spaghetti diagram training so they know why they're being asked these questions, and they have the knowledge too. They often could say, oh, it's crazy, I'm moving this from over here to that person over there. Why don't we move them closer together? So it's good to engage everybody involved, and identify waiting areas too and bottlenecks. So if you see a pile of components at a workstation, that's usually signals that's a bottleneck there, and that's causing waiting time in the system. So you want to try to eliminate those. And if you need help with this, we can help you. We can come in, draw your current operation in AutoCAD, and help you analyze the flow of your operation. So that's something we can do to help you. So any questions on this at all?
Andrew or Kirsten, anything you want to ask directly to Ted?
I do have a question. So with the saving of steps, if you're setting it up so it's conducive.
I can't hear you too good, I'm sorry.
I'm sorry. So when setting up the space, right, and you're looking to reduce the amount of steps and reduce the amount of time, I'm in a situation where we're rearranging based on what is being built. So what would your suggestion be to reduce steps in time in that instance?
So you're rearranging based on what the customer orders?
What we're building. Like something might be smaller. We might have two different things going on at a time. Something might be larger. So there are different configurations and different setups.
Yeah. Yeah, one thing that we've done is we try to make mobile workstations as much as possible, put everything on casters, and in advance come up with the layouts, the best layout for each product or that you're making, and have it so it's very easy to rearrange into possibly like a work cell. So you move workstations out and other ones in, and the ones you aren't being used, put them off to the side of the walls, out of the way. And so we helped a company that processes food, and they have different seasons. Like at one part of the season, they're making applesauce, and then other part of the seasons they're pickling beans, and they're doing other all different types of products. So seasonal based on the vegetables that are coming through and the food that they have coming through their operation. So we did that one, a very flexible workspace with flexible workstations on casters that they can rearrange based on the season. And in that case, we came up with layouts and processed, a good, nice flow that we'd map out in advance. So then when they're making applesauce, they already have it mapped out what the operation will look like, and they rearrange it based on that. So that's why we try to do that. Do you think you could do something like that?
So we do have tables on casters, and we do move things around. We have thought about taking, pictures of how something's set up depending on what we build. But we build thousands of different things. So it's just a matter of finding what's the best layout for the day, I guess. Yeah. And then how to make it work efficiently.
Yeah, if you could do time studies on the operations, it really helps out too, so that when you group the workstations together, how many people you need to run it is an important thing. So yes, that's the way I did it in the automotive company. We would have different arrangements with different amounts of people based on in some cases, based on the customer demand. One person might be able to do 2 operations, one person might be able to do 3. But you got to look at the customer demand on the product and the time it takes for each operation to see how to regroup it. So, and you can come up with multiple layouts on the same product based on the customer demand. But the ideal way is it takes work, but is to have a new arrangements predetermined based on customer demand. And when we did this for the automotive industry, like Ford would want to know our arrangements for 100 pieces an hour, and they wanted to see our arrangement for 50 pieces an hour or 25 pieces an hour, because they wanted to pay the lowest amount of cost for the labor, and they wanted to make sure each one was productive. So we had to show them different arrangements, and they would actually have a lean team come in from Detroit of like 10 people and analyze the operations based on the different outputs, and it was pretty amazing how thorough they were with that. So that's what I would recommend. You have to get time studies on the operations too.
Incredible. That's incredible.
Yes, we are in the process of doing that. So it sounds like I'm on the right track.
Yeah. So, and I would
Thank
suggest,
you.
Kristen, sometimes having another person come in, like Ted had the folks come in from Ford, right? And we go in, and sometimes having that extra set of eyes. What I know that Ted worked on another client, and the client said was that when they first started, they thought they were going to have like 125 different layouts and 125 different diagrams, right? But then having Ted, having that outside perspective, there were actually kind of little segments that were standardized. And so being able to spot those things where it was standardized and then figure out how to standardize others, reduce the number of configurations. Because they stopped seeing it as all one giant crazy spaghetti thing and said, oh, look, this unit of it is this, and this unit of it is that. And that kind of worked out well. So that might be something, you know, just to kind of have an extra set of eyes and looking at it, that might be of value to you. Speaking of you, I do value your time, and I know that it's already 11:35. So I want to see if there are any other questions before we let Ted say goodbye. Ted, if you advance one more thing too, I know most of you, I think, are signed up for the full series, because this is one of the 4 productivity tools that Ted's going to be presenting. If you can go forward one slide, Ted, and that has the kind of the 4 things. So we'll have 2 on December 8th after the holiday, and then 1 on December 15th. And obviously, especially with what you're talking about, Kirsten, right? It's not just about figuring out the configuration, it's also then setting up within that configuration, right? So when Ted was talking about the tact time, right? That's a part of that as well. Yeah. So that might be another valuable tool, and we'll be discussing that a little later. But in the meantime, don't wait until December 8th. One more slide, Ted, if you would. I totally love giving away Ted's contact information because he is such an excellent resource, and we want to make sure that you know, folks are connecting directly with him. So if we didn't answer your question today, or if there's something that's a specific challenge that you'd like to ask before we ever get into the other 3 of the tools, this is the way you can get to Ted. Ted, any final words for friends about why you, again, are just so in love with spaghetti diagrams, especially, I think, as you said to me, kind of like one of the introduction tools to.
It's one of the easiest tools to really make process improvements right away. The other ones I'm going through are there's more work involved in them, but they're all valuable. All the other ones in this series, but the spaghetti diagram is the easiest one to implement immediately, and you got huge benefits from it. And if anybody wants me to come in and take a look at your operation, I could just come in for an hour and see what's going on. And, you know, if you want, you know, if you need any guidance, just let me know. So, but the other ones I'm going to be going through in the future are very valuable too. So they're all a little different, but they all have a lot of value to them. So, but if you have any questions at all, just contact me by email or feel free to call me. We're here to help you guys be very successful in Rhode Island. So anything that I can do to help you guys, just let me know.
So. Thank you all for your time today. I will follow up with an email that has all of Ted's contact info and a copy of this deck. And we look forward to continuing this discussion of how to improve our productivity by using these proven tools. Thank you, Ted. Thank you.
Yeah, thank you for coming. Bye.
Thank you. Bye.
Bye.